Hi everyone, welcome to goclasses. Before we start, please tell me, is the audio video volume, is everything fine? Please let me know. So let's start the session. Today we had All India mock test for GATE 2023 exam, and so the response was very good. I know that all of you loved the session. There were some problems on the end of some students. There were few students who had some issues during the exam. So those issues will be corrected next time, because we will have All India mock test second test. Okay, so it will happen on the 22nd January. Okay, so basically next Sunday it will not happen, the Sunday after that. Okay, so we will have All India mock test, goclasses All India mock test for GATE 2023, another mock test, second mock test we will have. Okay, as I told you, the Sunday after the next Sunday. Okay, so on 22nd of January we will have that. Okay, so now in this session what we will do, we will solve the theory of computation questions. TOC question solutions we will see in this session. The detailed solution of each TOC question I will tell you. Okay, so let's start now. So just want to tell you that all the questions you can access by this link, and this link you will find in the description. Okay, so you can check out the description to find out the link for All India mock test 1 questions. Okay, so now let's move on. This is just a small announcement that if you want to attempt all the GATE overflow plus go classes mock test, there are 15 mock tests. Okay, in the test series. In this test series we have this test series. You can see GATEOverflow plus go classes, this combined 2-in-1 test series, this combined test series has 15 mock tests. Okay, so if you want to subscribe for all the 15 mock test only, if you want to attempt all the mock test, then what you can do, you can find the link in the description. You can subscribe for GATEOverflow go classes mock gate test. Okay, so there are total 15 mock tests in this package. You will find all the 15 mock tests of GATEOverflow plus go classes test series. Okay, all these mock tests are quality mock tests. So these are basically the GATE worthy mock test. Okay, so you can subscribe for all the 15 mock tests and you can start attempting. Okay, the link you will find in the description. So let's move on now. Now let's start the session. So we are going to solve theory of computation questions. Let's start with this question. This is our question number 1. Let's solve it. In the Go classes All India mock test 1, this is our question from the theory of computation. And the question is saying that you have to build push down automata. This push down automata you have to build simulating a natural language processor recognizing natural numerical palindromes of even length. Okay, so numerical palindromes of even length, this is what we want to recognize. Okay, we want to recognize numerical palindromes of even length. This is what we want to do. So what are the numerical palindromes of even length? So let's see this. So what are the numerical palindromes? Numerical palindromes. Okay, numerical palindromes. So for example, you can see that this is a numerical palindrome. I can say 98989. This is a numerical palindrome. This has odd length. Correct, this has odd length. For example, you can have another numerical palindrome that is like 2113. Okay, and then you can have 3112. This has even length. So like this. Okay, so like this you can create numerical palindromes of odd length, even length. This is how you can create. Now the question is asking that we want to create a push down automata to recognize numerical palindromes of even length. This is what we want to recognize. Okay, then the question is asking which of the following grammar will help you build the solution. Which following grammar will help you creating this push down automata for this language? So this answer is very simple. For example, whenever you have this alphabet, like if your alphabet is A, B, if this is your alphabet, then how to write the grammar for all palindromes? So let's check it out. So how to write grammar? If you want to write grammar to recognize all palindromes, or I can say to recognize all, I can say even length palindromes, for even length palindromes. So for even length palindromes, how can you create the grammar? The grammar you can create very easily, because what happens in a palindrome? See, palindrome basically is recursive structure, correct? This palindrome, this is a recursive structure. This is a recursive structure, this palindrome. What this recursive structure says? This recursive structure says that the first symbol, okay, so the recursive structure says that first symbol will be same as the last symbol. This will be same as this, and inside again you have a palindrome. Again here you have a palindrome. So this is a recursive structure. What I can say, let me just tell you what I mean by recursive structure. This recursive structure means I can say that a palindrome is equal to, okay, a palindrome is equal to basically first symbol, last symbol, they must be same. So this first symbol, this must be same as the last symbol, and inside also you have, here also you have a palindrome. Here also you have a palindrome. So you can see this is a recursive structure. If this is your x, then this also should be x, and then okay, in between also you have this palindrome. So this is your recursive structure. And remember, whenever we have a recursive structure, then recursive structure can be recognized by CFG. Okay, if you want to recognize this recursive structure, to recognize these recognized by context free grammar, so you can recognize them by context free grammar if you have a recursive structure. This is a gate question also. This question is another gate question, okay, that context free grammar is used to recognize recursive structures. So you can see palindrome is a recursive structure, and in this recursive structure you can do like this. Now let's see how to create even length palindromes. So even length palindromes you can very easily create that the starting variable, or I can say this starting variable, the first symbol and last symbol must be same. In between you can have a palindrome. So remember, this denotes palindrome. This denotes even palindrome. Okay, so this S, this denotes even palindrome. Then you can easily see, if this denotes even palindrome, then you can easily see that the first symbol and last symbol must be same, and in between again you have palindrome. Similarly, the first symbol and last symbol must be same, then in between again you have palindrome. Okay, and remember, because we want even palindromes, so finally, because this even palindrome we want, so finally I can say you can this termination will happen. This is the termination of recursion. This is the termination, okay, of recursion. This is the termination of recursion. So termination of recursion will happen by this empty string, because you want even length palindrome. So that is the reason termination of recursion will happen by empty string. Okay, now if you want odd length palindrome, then how to do that? Let's see. If you want the odd length palindrome, that idea is very simple. Basically, now the termination will happen with one symbol, either A or B. This is your alphabet. So now you can notice that this S denotes odd palindromes. This denotes odd palindromes. Now you can easily see that you can write recursively that the first symbol, last symbol must be same, and in between again you have odd palindrome. Similarly, the first symbol, last symbol must be same, and in between again you have odd palindrome. And finally you can notice this is an odd palindrome, this is an odd palindrome. Okay, so this is how you can solve this question very easily. This is your answer for odd palindromes. Now you can notice these are the termination conditions. These are the termination conditions for odd palindrome. Okay, so you can see this is the termination for odd palindrome, because S denotes odd palindrome. So that is the reason we terminate by odd palindrome. Okay, now the next is, if you want all length palindromes, then how can you do? All length palindrome, it means that this S will denote palindrome now. It will denote a palindrome. So now you can notice that first symbol, last symbol must be same. In between you can have a palindrome. First symbol, last symbol must be same. In between you can have a palindrome. Okay, and finally you can notice that because you want palindrome, you can notice this is a palindrome, this is a palindrome, this is a palindrome. So now this is your termination. In this question, now this is the termination. This is the termination of recursion. Okay, for the recursion, this is the termination. So this is your answer. Now you can easily see that this option number A, You can see that these are the alphabet. Alphabet is 0 to 9. This is the alphabet. In all the questions, this is the alphabet. Start variable is s. This is the start variable s. Now you can easily see that first symbol, last symbol same, first symbol, last symbol same. Okay, and finally you are terminating with lambda, which is empty string. So this will give you your answer. This will give you all the even length palindromes. This is going to give you all even length numerical palindromes. So this is your answer. Remember, this will give you odd length palindromes. So this is not your answer. And this will give you all palindromes. So this is also not your answer. But you can see option A is even length numerical palindromes. Option B, odd length numerical palindromes. Option C, that is all numerical palindromes. So for this question, the answer will be option A. This option A will be the answer for this question. Did you do this correctly? Tell me. In the in the All India mock test, in the Go classes All India mock test, did you answer it correctly? Or did you do some silly mistake? Let me know. So this is your complete analysis of this question. The question is asking for to recognize even length palindrome. If you want to recognize even length palindrome, then answer will be option A. For odd length numerical palindrome, answer is option B. And for all palindromes, all numerical palindromes, answer will be option C. Okay, let's move on now. So this question, I think this is an easy question. We can put this in a category of easy. Okay, I hope you agree that this is an easy question. This is a standard question. Now let's see. Let's see this question. This is another question from Theory of Computation in our Go classes All India mock test. So let's see this question. So alphabet is given to you. Let sigma be a comma b. This is your alphabet. Now the language is given to you. The language is L equal to a power n w a power n, where n is greater than equal to 1. W belongs to sigma star. This is the question that is given to you. Now you tell me, is this language regular? Tell me, is this language regular? So now you can see, let me tell you, this is a misconception many students have. When you by heart concepts, then you will do like this. Okay, so regular means no, see, what students do. This is what students do, that non-regular means matching. When you are matching, then it is non-regular. When you have comparison, it is non-regular. So this type of logic students give. Let me tell you, these are very poor logics. These are very poor logics. Okay, because see, this is not correct way. This is, I can say, this is a by-hearted. This is called by-hearting. This is called rote learning. This is called rote learning. That non-regular means there is a matching, there is infinite matching, there is infinite comparison. This type of logics are very poor logics. Okay. Now, first you understand this language. Like if you look at this language, what this language is saying. This language is saying that sigma is a comma b. The sigma, this alphabet is a comma b, and the language that is given to you, that is a power n, then there is w, then there is a power n, where n is greater than equal to 1, and w belongs to sigma star, and w belongs to this sigma star. Now first you understand this question. If you are doing this logic that, see, there is a comparison, many students, what they will do, oh, there is a power n, so there is a comparison, very good, and this is an infinite comparison. So okay, then they will do like this, that there is an infinite comparison. Okay, so because there is an infinite comparison, so the language L is non-regular. Very good. Okay, so if you do like this, then this is, let me tell you, this is very wrong logic, as I told you. Okay, so you can notice this is a wrong, this is very wrong thing. So anyway, now first you understand the language. Before you answer the language, first you understand the language. Okay, before answering this question, like, okay, if you apply this type of logic, then this is a very wrong logic. This is called rote learning. Okay, so don't apply this type of logic. First you understand the language. This should be your task. Forget about type of language. First you understand what are the strings in this language, what are not the strings in this language. First you understand the language. Forget about it is regular or not. Okay, forget about it is regular or not. Don't worry it is regular or not. Just understand the language. Understand the strings in the language. What strings belong to the language, which strings do not belong to the language. Understand strings in the language. Understand which strings belong to L. Okay, This is what you understand. Before solving this question, first you at least understand the language, what this language is saying. Then you find the type of the language. Okay, now let's see. So now let's see in this. So you can easily see that first of all, n is greater than equal to 1. Now you can easily see that every string will start with a, because n is greater than equal to 1. What you can say? You can definitely say that whatever string belongs in this language, whatever strings belongs, okay, that string definitely starts with 1 and ends with 1, because n is greater than equal to 1. So you must have a power 1 at least. So it must end with a. Okay, there is no deny. This is correct. Very simple. This is extremely simple. Now the question is saying that okay, now the question is saying that now you have some a's you have. So like this, you have some a's, and same number of a's you have at the end, and in between you have some w. This is what the question is saying. Now I am saying that every string which starts with a and ends with a will be in this language. Okay, so you can notice this is the format of this language. Okay, in this language every string should start and end with a. Okay, I am also saying that if a string starts and ends with a, if you have this type of string, then it will belong to the language. If your string is starting with a, ending with a, so this is your string, okay, then definitely this string will belong to L. Okay, why? What is the reason? Very simple. Because what you can do, you can fix this n equal to 1, and you can take the entire middle string as w. You can consider this entire middle string as w. Okay, this entire string you can consider as w. Now you can see that all the conditions are satisfied. W belongs to sigma star. This condition satisfied. N is greater than equal to 1. This condition satisfied. All the conditions are satisfied. So finally what we can say two things. This is your language a power n, w a power n, where n is greater than equal to 1 and w belonging to a comma b whole star. Okay, in this language what we can say that if your string has this format, then this will belong to L. Okay, then this will belong to L. Okay, so if your string, for example, some string y you have, this is your string y. Now I am saying that if then y will belong to L. Okay, because what you can do, you can consider this entire part as w. This entire part you can consider as w. So you can see that in this situation y will belong to L, and if y belongs to L, then definitely it will have this format. So this is if and only if. Okay, this is if and only if. That if your string has this format, it will belong to L. Okay, is this understood? Please tell me, is this question understood, that if your string has this format, then it will belong to L, and if your string belongs to L, then it will have this format. So finally you can see this is if and only if. So we can say that this language L, this is nothing but, okay, now let me tell you. So finally what we can say that this L is nothing but starting with at least 1a, ending with at least 1a. In between you can have anything. In between you can have sigma star. So you can see this is a regular language. Okay, let me tell you that this is same as this. This regular expression is also correct. These two regular expressions are equivalent. Okay, very simple. So you can see that answer will be what? First you understand the language, then you can easily say that this is a correct answer. A plus b whole star a plus, this regular expression is correct. Let me tell you, this regular expression is also correct. So let me write here regular expression for L. So what are the regular expressions for L? Regular expression for L will be like a sigma star a. This is also correct. A plus sigma star a plus, this is also correct. Okay, so both these options are correct. Is this clear? Let me know. So very simple, this is your correct option. There exists a context-free grammar for L. Of course there exists a context-free grammar, because every regular language is context-free language. This is a regular language. This L is a regular language. You can note this is a regular language. Every regular language is CFL. So definitely there exists a context-free grammar for this language. Okay, so because it is context-free, so it means there exists a context-free grammar. Okay, so finally I can say that both the statements are correct. Did you do this correctly in the mock test? Did you correctly do this? Tell me. In the mock test, did you do this correctly? Let me know. Twinkle is asking what is the correct way to judge if it is regular or not. First, you understand the language. Twinkle, if you want to check about the regularity, okay, how to check regularity? Let me tell you. Regularity of a language. If you want to check regularity of a language, the first way is understand the language first. Okay, before checking the regularity, before checking the type of a language, first you understand the language. This should be your first step. This is very important. See, whenever some students, there are many students, what they do, when they see the language, immediately they want to find the type of the language. Immediately they want to just find the type of the language. They don't want to understand the language. They don't want to understand what strings belong to the language, what strings do not belong to the language. They don't want that. Okay, they just want what is the type of the language. So first you understand the language. Then what you can do, then you can easily see if you can create DFA, or NFA, if you can